We're now going to step up the complexity a little bit with our Venn diagrams and interrogate some new data. So I've got an example for you up here. A class of 20, as we can see here, were surveyed about their devices. They were asked whether they had a desktop, a laptop, or both. And we can see that 6 people had a desktop, 7 people had a laptop, 4 people had both, and 3 people had neither. So that's our data that we're going to be working with here. Now we've got to interrogate this a little bit more. We're given slightly less information. The total number of students with desktop in the classroom goes across 2 categories, because we've got people who have just got a laptop, 6 of them, and people who have got both a desktop and a laptop. So to find out the total desktops, we need to do 6 plus 4, which equals 10. So we've got 10 people overall who have a desktop. The same with laptops. We've got 7 people with laptops, but 4 people with both. 7 add 4, so we've got 11 people with a laptop. So let's do some probabilities then. We can calculate the probability of picking one student who has a desktop. Alright, so that's equal to 10 over 20. Which is 0.5. So our favourable outcomes are 10, and our total possible outcomes are 20. So we've got a half, or 0.5, or 50%. Now we can look at the probability of having a laptop. So here we've got 11 people. Alright, so we have now got, we can't simplify that down anymore, but that is 0.55 or 55%. So we now know the probability of those who have a desktop or a laptop, or picking a person who had a desktop or a laptop. And we can work out whether people had no desktop in one of 2 ways. So we can either look at, so let's try these 2 examples over here. So if they do not have a desktop, there's the long version. So we know that if 10 people did have a desktop, then we have a 7 and a 3. So these people did not have a desktop. So we know we've got 10 over 20. So again, a half, 0.5, or 50%. Alright, so it's half a chance of them having a desktop, half a chance of them not having a desktop. But the other way we can work that out is to use the information we have already processed. We know that there are 2 events. We either have a laptop or we don't within this set of data. We know that there is 100% certainty that the people in this survey will either have a laptop or they won't. There's no possibility outside of that. So out of 100% possibility, or a 1, we can minus the probability that we've already worked out, which is 0.5. So 1 minus 0.5, and that gives us 0.5, which matches our chance that we've worked out here. So our total possibilities, or our total probabilities, for events that are either one or the other must add up to 1. We can also work out the probability of having both, and the probability of having neither. So now we're going to make it a little bit more complicated by adding the and, not, or language that we looked at before. So for example, we can do the probability of someone having a desktop or a laptop, but not both. So a desktop or a laptop, but not both. So let's have a look at these together. So we want the probability of someone, we can break this down, the probability of having a desktop, add the probability of having a laptop, but not both. So we're not including this 4. So we know that we've got our 2 fractions then. The desktop was 6 over 20, and having a laptop was 7 over 20. Adding these fractions is nice and easy because our denominators are the same. 6 and 7 then is equal to 13 over 20. and you can then convert that into a fraction and a percentage depending on what the question has asked you to do. If you look through the lesson slides on the PowerPoint, it goes through this example in even more detail and steps up the complexity even more if you feel like you're ready for that.